Okay, so section 5.4 part 1 is on factoring polynomials. Alright, so you know numbers factor, like I just did with 27. 27 breaks into 9 and 3, and then 3 times 3 times 3. Right, 100 breaks into 10 and 10, and then 2 and 10, or 2 and 5, 2 and 5. Right, polynomials are the same way. So polynomials are going to continue to break down until we have prime factors. Okay, so it's called a prime factorization. Okay, so the first method that we're going to talk about is pulling out a greatest common factor. Okay, so this is called a GCF. So the greatest common factor is kind of the opposite of doing like 2xy multiplied into 3x squared y plus 1xy squared, right? We did that where we multiplied something in. We're going to do the opposite. We're going to pull that number that's in common to both of them out. Okay, so it's like we're dividing it to the front. All right, so on this one, I have 10a cubed b squared, and I have 15a squared b minus 5ab cubed. So when it comes to the numbers, 10, 15, and 5, they have a factor of 5. And then my a's, I have a cubed, a squared, and a, so I have an a in common. And then the b's, I have a b squared, b, and b cubed, so they all have one b in common. So in parentheses, I would need a 2a squared b, right? So that if I did multiply it back in, do you guys see how you would get 10a cubed b squared again? So it's like I only have one a, I need 2 more. I only have one b, I need 1 more. All right, now the next one, I would need plus 3, and then I need 1 more a, and I'm good on the b's, right? And then the 5ab cubed, I need a negative 1. I have enough a's, I just need a b squared. So you could say negative 1b squared, or you could just write b squared. So if you multiplied back in to check, you would end up getting exactly the same thing that you had up here. So you're good. Okay, so I call this factoring with the GCF method, greatest common factor, or I often will say, like, pull the greatest common factor to the front. Pull it to the front. All right, so this one. So I have 3a squared b to the 4th minus 12ab cubed plus 24a squared b to the 5th. So I have a 3 in common. I have a squared a and a squared, so I can only do 1 in common. I have b to the 4th, b cubed, and b to the 5th, so I have 3 b's in common. Yeah. Uh-huh.
You have 2a squared. How's that work?
You got it? All right. So the next one. So when I pull out the 3ab cubed, I'm going to have, I need 1 more a to make a squared. I need 1 more b to make the b to the 4th. So I just have ab. Then I'm going to have minus 4. I'm missing an a. I'm not missing a. I have all my a's. I have all my b's, so I'm good. So it's just 4. And then plus 8. I only have 1 a on the outside. I need 2 total, so I need another a on the inside. And I have b cubed on the outside, so I need b squared. So that's the factored form. So it's just pulling out a GCF.
Why do you have a minus 4?
Because when I multiply back in, I need to be able to get that. Like if I do 3ab cubed times negative 4, that's giving me the negative 12ab cubed. All right, so the next thing we're going to talk about is difference of 2 squares. Okay, so on number 1, I have x squared minus 81. Okay, the way this factors is the x squared is x times x, and the 81 is 9 times 9. So you end up getting x plus 9 and x minus 9. So you can check, right, if you FOIL it out, like double distributive property, you'd have x times x is x squared, x times negative 9 is negative 9x, 9 times x is 9x, 9 times negative 9 is negative 81. You see how the 9's cancel out, negative 9x and positive 9x? That's how you're left with the x squared minus 81. So we're good. So these are ones where it doesn't have like an x term. It just has x squared and a number, and it's a difference between them. It's a minus in between. So it's basically the exact same thing in the 2 parentheses. It's just one has a plus, one has a minus. So on this one, I have 25x squared minus 16. So yes, this is the difference of 2 squares, because 25x squared is 5x times 5x, and 16 is 4 times 4. So when I break it up, I'm going to say it's 5x plus 4 times 5x minus 4. That's what makes the x terms go away, right? Because the outer and inner, I call them swoops, like the outer and inner swoops, make negative 20x and positive 20x, they go away. Okay, so it works. How about x squared plus 4? That's what a lot of people think, like x plus 2 times x plus 2. But if you go ahead and you multiply it out, right, x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2 times 2 is 4. Right, do you see how the x terms don't go away? You have 2x plus 2x, so you end up getting x squared plus 4x plus 4. So you don't have a plus 4x in there, right? It's like 0x. So what do you guys think? Yeah, you would think like x plus 2, x minus 2. Alex, what do you think? Plus 4, like x plus 4 times x plus 1. Same problem, right? Because the outer and inner, now they make 4x and 1x. Still a 5x. So how are you getting 0x? How is it going to happen? Yeah, Emerson? Nope, because that'd be x squared minus 4x plus 4 if you did x minus 2 and x minus 2. Jason, what do you think? Yeah, you can't do it, right? Exactly. So this is what we call prime. Just like numbers can be prime, like 17 is a prime number. It doesn't factor any further. Polynomials can be too. So the sum of two cubes, or sum of two squares will always be prime. It doesn't work. You can't do the sum of two squares. Okay, how about number 4? It doesn't quite look like the difference of two squares, but what can we do first? Yeah, do the GCF right. So I'm going to pull out the 5y, and I'm left with x squared minus 25. Now you can see the difference of two squares, right? So it's going to be the 5y is just out front, and then the x squared minus 25 factors into x plus 5 and x minus 5. And we're done. So on your test, I never put a prime one, because back when I used to teach at another school, I would say, okay, 2 of the answers are going to be prime, like on the test. And then I would have students that would write prime on every single one. They're like, at least I know I got 2 right. I'm like, now you got 2 out of 100. Like, good job. Like 2% for your test score. So I don't put prime on the test anymore. Yeah, okay. Sometimes I make mistakes. Sometimes I think it factors and it doesn't. All right, so next one. So it says you've also learned how to do factor by grouping. So you guys did this in Algebra 1. Okay, it's been a while, I know. All right, so I sometimes call this split the middle. So what we're going to do is if we have like 4 terms or 6 terms or 8 terms, an even number of terms, we're going to split it straight down the middle. So I'm going to split right there. And I'm basically going to ignore the right side at first. So I'm taking my hand and I'm like totally covering up the right side. Now don't do this on your notes. Don't scribble out the right side. But if I just have x cubed minus 6x squared, how would I factor if I just had x cubed minus 6x squared? What would I do? X what? No. X squared. So you're going to pull out an x squared, right? You're going to pull out what they have in common. And you'd be left with x minus 6. Okay, now imagine I'm covering up this other side. Okay, now I have 2x minus 12. What do they have in common? A 2, right? Do you guys see how you also get x minus 6 left? So we're going to have x minus 6. And I'm going to always pull out a number and a sign on that second one. So not only am I pull out the 2, but I'm going to pull out a plus sign as well. So plus 2. So number and a sign. Okay, here's where it gets really weird. So make sure you're paying attention to this. All right, if I gave you x squared w minus 2w, you guys would be like, oh, I know how to factor that. I'm just going to pull out the common factor. Like, all of you would understand that. You'd be like, oh, the w is going to go to the front. I'm going to have x squared minus 2. Do you guys understand what I'm saying? Okay, this over here is in that form. The x minus 6 is the thing that's in common. Think of it like a w, right? X squared times something plus 2 times the same something. It has a common factor. So what we do is we pull that common factor to the front. So x minus 6 goes all the way in the front, parentheses and all. And then we write what's left, and we put it in parentheses, just like we did over here. So we're going to have parentheses x squared plus 2. And then that's it. We've now factored. So we pull what's called the common factor, that whole thing in parentheses, to the front. Okay, notice how I didn't write x minus 6 squared. A lot of people do that. Or they write 2x minus 6. There's only one of them. You pulled that one factor to the front. All right, so same thing on this next one. So I'm going to break it apart. So I'm going to pull out an x squared on the left side, and I'm going to be left with x minus 1. Now I know that I want the same factor that x minus 1 on the right side. So is there a number that I can pull out to get x minus 1 on the right side? 25, but negative 25. Do you guys see it? Yeah, so you can always check if you multiply back in, you get negative 25x plus 25. That's a big mistake people do. They forget the negative. They just do 25. And then they try to put like x plus 1 on the other side. You want these two things to be identical. Okay, so now that you have that same factor, it is now a common factor. Yeah?
Can you do x, let's see, x squared minus x squared?
No, you always want to pull out the biggest thing that they have in common. All right, so I'm going to have x minus 1 goes all the way to the front. And then I'm left with x squared minus 25. Am I done? No, your homework has a lot of these, a lot of difference of two squares ones. So now you can see you have the x minus 1 like you had, but x squared minus 25 factors into x plus 5 and x minus 5. So make sure you go all the way down. Just like prime factorization of numbers, right? If I had 210 and I break it into 21 and 10, I have to keep going until I'm all the way down. Okay, so same thing. All right, number 3. So we have 12x cubed plus 3x squared minus 24x minus 6. Okay, so a lot of you guys probably don't notice that it has a common factor for all of them. Do you guys see that there's a 3 in common to all of them? So what I'm guessing is you guys have already started it and you've split the middle. That's fine. We'll go with it. Okay, so let's say we split the middle. Then I would pull out a 3x squared, and I'd have 4x plus 1 left. And over on the right side, the negative 24x minus 6, I know I want 4x plus 1. So I pull out a negative 6. Do you guys see? So now I have the 4x plus 1 in common. It's here and it's here. So I'm going to factor it all the way to the front. So I'm going to have 4x plus 1. And I'm left with 3x squared minus 6. But I'm not done. Because 3x squared minus 6 actually has a GCF. What does it have? A 3. So we put a 3 all the way out front. And then we have 4x plus 1. And then we have x squared minus 2 left. Can I factor x squared minus 2 with difference of two squares? No, because it's a 2, right? You can't do like 2 and 1 or anything like that because you'd have an inner term. You wouldn't get 0x. So then we're done. Now, if you guys are good factorers, what you'll do right from the beginning on number 3 is you'll be like, oh, I have 12x cubed plus 3x squared minus 24x minus 6. They all have a 3 in common. And you're going to pull that 3 all the way to the front. So you'd have 4x cubed plus x squared minus 8x minus 2. And then you'll go from there. So then you'll split the middle. So you'd have x squared, 4x plus 1, minus 2, 4x plus 1. And you still have that 3 all the way on the outside. And so then in the end, you would get exactly the same thing. You'd get that at the end. Okay, does that make sense? Okay, it's not a huge deal if you forgot to pull out the GCF at the beginning. But later on, as we're factoring more complicated things, it's going to save you a lot of time if you look for that GCF. If you don't, then you're going to waste like 5 minutes on a problem just trying like different things. All right, so we just talked about the factoring the difference of two squares. So we said if I have something that's in the form a squared minus b squared, it factors into a plus b times a minus b. Okay, now we're going to move on to the sum and difference of two cubes. This is something that you did not do in Algebra 1. This is new. Okay, so if I have a cubed plus b cubed, there's a pattern. It's always going to factor into a binomial and a trinomial. Binomial means 2 terms, trinomial means 3 terms. So if I have a cubed plus b cubed, the first parenthesis, I'm just going to drop the cubes. I'm going to have a plus b. And then the second parenthesis, there's a pattern. So I'm going to square the first item. First item means like this a. I'm going to square it, and I'm going to have a squared. And then I'm going to square the second item, b, and I'm going to have b squared on the end. And then in between the a squared and the b squared, I'm just going to take these two things right here, and I'm going to multiply them together. So I'm going to have whatever number's here and whatever number's here, I'm going to multiply them and have a times b. Okay. And then your signs are always same, opposite, always positive. So same means if it was a plus before, then your first sign is also going to be a plus. So same. Opposite means you're going to change it, so now it's minus. Always positive, so plus. So same, opposite, always positive. Spells out soap. So same, opposite, always positive. So these are always a pattern. So you just break it up into binomial, trinomial, and so on. Okay, so same idea if you had the difference of difference of two cubes. So you're going to have a minus b, you just drop the cubes. You square the first item, a squared. You square the last item, b squared. You multiply the two items together, ignoring the sign, right? A times b. And then it's same, opposite, always positive. Okay, so that's the pattern. So we'll do several of those. Yes?
So how does a squared of a cubed minus b cubed is the same as?
A lot of people think, is this where you're saying a cubed plus b cubed? Why is it not a plus b cubed?
But no, it's not that.
That's like the opposite of the freshman dream. Remember the freshman dream we talked about last time? Yeah, can't do that. You can't just bring a cube in to both of them. That doesn't work. So don't do that. So what are you asking then, Yaya?
I mean, so how would you be able to get the equation we just did back into a cube?
You would multiply it out. So you'd take the a and you'd multiply it in here, here, and here. Then you take the b and you multiply it here, here, and here. It's a long process. That's what we did in 5.2. All right, so it says be careful. The squares and cubes rules are completely different. So you really have to pay attention. Do I have squares or do I have cubes? What am I dealing with? So the first one, I have 16x squared minus 9y squared. So these are squares, right? It's the difference of two squares. Edward, you with me?
Yeah.
All right, so when I factor it, notice how this is 4x times 4x, and this one is 3y times 3y, right? So when I do my difference of two squares, it's just the thing where it's like a plus b times a minus b. So I'm just going to have 4x plus 3y times 4x minus 3y. And if you multiply it all out, so FOIL it out, you will get that, right? The outer and inner terms cancel each other out. So same thing on the next one, also difference of two squares. This is 5xy squared times itself. So I'm just going to write squared. And then this one was 12z is being squared. Using it, so 25x squared y to the fourth was 5 times 5, x times x, y squared times y squared. So when you factor it, you're going to do your two sets of parentheses, and you're going to have almost exactly the same thing in both of them, but the signs are going to be different. So 5xy squared plus 12c, and 5xy squared minus 12c. Yes? Oh, 12z. 12z. All right, so the next one. So I have x cubed plus 8y cubed. Now I have cubes, right? So this is the sum of two cubes. So what I first do is I write what is being cubed. So I'm like, oh, if I have x cubed plus 8y cubed, that's like x is being cubed, and 8y cubed is like 2y in parentheses cubed. Does that make sense? So I always like to see what's being cubed before I start the problem. In other words, I'm identifying what the a is and what the b is for my formula. Okay, so now I'm going to break it into a binomial and a trinomial. So I'm going to have a small one and a long one. So the binomial, I just dropped the cube. So it's like I just kind of cancel out these threes. I get x plus 2y. So I have x plus 2y here. And then for the trinomial, I look at each, like the a and the b. So this is my, like, a, air quotes. So if I have x and I square it, x times x is x squared. That's what I put here. And then on the end, I do 2y times 2y. So if I have 2y times 2y, that is 4y squared. And then I multiply the two items together. So if I have x and 2y together, I'm going to get, oops, not plus, it's going to be minus. I'm going to get 2xy. So my signs are same, opposite, always positive. It's a minus in there. It's kind of hard to see. Minus 2xy. 2xy. So it's x plus 2y times x squared minus 2xy plus 4y squared. Okay, so let's try another one. So if I have y cubed minus 125, do you see that it's y is being cubed and 5 is being cubed? Right, 5 times 5 times 5 gives you 125. So I do my two sets of parentheses. So one's going to be 2 terms, one's going to have 3 terms. So little parenthesis, long parenthesis. In the first one, I just dropped my cube, so I have y minus 5. In the second one, I square the first item, so y squared. For the 5, I square my second item, so I get 25, right? 5 times 5 is 25. And then I multiply the two together, so I get 5y. Caroline, can you close that door, please? Thank you. All right, so my signs are same, opposite, always positive. So negative, plus, plus. You always square the first item that was here. So if you had y here, then you do y squared here. Yeah, Faisal? What are you talking about? Oh, like this one? Yeah, it's negative. It's 5 times 5, so 25. Don't worry about the signs. Just worry about this is like A and this is B. So this is the B term squared. Okay, so a lot of you guys might wonder how this works, because I think you guys noticed, like, if you have y times y squared, that's how you're getting y cubed, right? And if you have 5 times 25, that's how you're getting the 125. But then people are like, well, what about that 5y? How's that coming into play? So I want to go ahead and show you this. I want to show you what you get when you multiply it out. So you don't have to write this in your notes unless you really want to see it in your notes. But basically, if I take the y times y squared, I'm going to get y cubed. Y times 5y gives me 5y squared. And then y times 25 gives me 25y. And then I go through and I do the same thing with the negative 5. So I get negative 5 times y squared is negative 5y squared. Negative 5 times 5y is negative 25y. And negative 5 times 25 is negative 125. And I go through and I cancel. So see how, like, I have a 5y squared and I have a negative 5y squared, so they go away. And I have a positive 25 and a negative 25, so they go away. So kind of like the difference of two squares, how you had the outer and inner terms canceling, like the swoops. Same thing happens with the sum and difference of two cubes. Like, you're going to have a lot of things in the middle that cancel, and that's how you're left with y cubed minus 125. So it seems weird when you first see it. It's like, why does this work? Because, like I said, every year on the test, someone will write y minus 5 cubed, right? Someone's going to do it. So you can make fun, and I can say this a million times, like, oh, I hate when people do that. Oh, it's one of my big pet peeves, and then you guys are going to do it. So don't do that. You can't just, like, pull out the cube. Doesn't work that way. All right, so the next one. So always think about what is being cubed. So I have 3p is being cubed, and 5q is being cubed. So I've identified what A is and what B is in the formula. So when I do my parentheses, I'm going to have a little parenthesis and a long parenthesis. So in the little one, I just have 3p minus 5q. It's like I just dropped the q's, or dropped the cubes. All right, in the first spot right here, I'm taking the 3p and I'm squaring it. 3p times 3p is 9p squared. In the spot back here, I'm taking the 5q and I'm squaring it. So I have 25q squared. And then in the middle, I'm just multiplying these two things together. So 3p times 5q is 15pq. Guys, pay attention. My signs are same, opposite, always positive. So that's my answer. Okay, so number 6 doesn't really look like the difference of cubes. Yeah. If you weren't talking and paying attention, my own mentee right there. I'm talking to Tyler Watt. All right, so you multiply these two things together.
No, I was just asking what it is.
Yeah. It's 15pq. All right, so this next one. So it doesn't look like the difference of two cubes, right? Do you guys see what we need to do first? Yeah, pull out that GCF. So we're going to pull out the 4 and the t squared. So I'm going to have 4t squared. And then on the inside, I have t cubed minus 8. Okay, now you can see the difference 2 cubes. So if you need to write it as t cubed minus 2 cubed, that can really help you. A lot of people will do t minus 8 in the first parenthesis. It should be t minus 2 in the first parenthesis. Give myself some more room. Okay, so I have 4t squared is just on the outside. And then I had t cubed minus 8. So I'm going to have a binomial and a trinomial. So in the first one, I'm just going to have t minus 2. And in the second parenthesis, I'm going to square the first item, square the last item, multiply the two together. Same, opposite, always positive. So same, opposite, always positive. Okay, do we feel good about those? Yeah. It's something, like I said, you didn't learn it in Algebra 1, but it's just a process. You just have to memorize like the steps, and you'll be fine.
I think it's t cubed minus 2.
I thought about what was being cubed to get 8. Like 2 times 2 times 2 gives me 8. And then t times t times t gives me t cubed. It just hangs out in the front. Like the 4t squared. It's just out front. All right. Okay, so moving on to the trinomials. These are the ones that make you guys panic a little bit. Fear in your hearts from Algebra 1. It's okay. We'll be fine. Now, Mr. Morrison in Algebra 1, if you guys had him, he teaches a different method, which is like multiplying the A term by the C term and all of that. Did you guys do that? But the problem with that method that I find every year is people forget it, and then they come to me and they're like, what's that way that you factor? Like, I know there's some kind of shortcut. How do I do this? So I'm not going to, like, I don't want to continue teaching you something that you're going to forget when you go to take the PSAT or SAT or whatever. Like, I don't want to teach you something that you just constantly forget unless you're in that chapter. So what I do is I relate it to FOIL. So we're unfoiling, okay? So this is sometimes, I call it the guess and check method sometimes. But it's really not, like, there's a process. There's going to be things that it's going to make it easier and so on. So I'm going to teach you some little shortcuts. All right, so it says factor the trinomial. So I have 3y squared minus 2y minus 5. Okay, so what I'm going to do is I'm going to unfoil it. I'm going to set it up so I have my two parentheses. And I first have 3y squared. So in these first two spots, if I was multiplying it out, those are the ones that are multiplying to be 3y squared. So I'm going to need 3y and y in those first spots. Okay, and my last two spots, this one and this one, they multiply to be the number, right? Those are just numbers. When you multiply them together, we're going to get negative 5. Okay, so I need those numbers to be like 5 and 1. Now, it matters where you put it. Yeah, one's going to have to be negative, one's going to have to be positive. So let's say I put the 5 on the right side and the 1 on the left. That's when I think about my swoops, as I call them, the outer and inner terms. Okay, and you guys are going to get very good at this. I promise you will get very good at this. And when you're visualizing, here's what I'm visualizing in my head. These two together, these two together. I would have 1y and I'd have 15y. Is there any way that I can add those together, even if they were opposite signs like they will be, to get negative 2? No. 1 and 15 are going to make 14 or 16, right? It's not going to work, or negative 14. So we've done something wrong. So I never move my 3y and my y. I just move my other two numbers. So what I would do is I would draw a line through it, meaning that you've tried that. Because on your test, if you just leave it blank, you're not getting any points, right? I want to know that you tried stuff. And let's put the 1 here and the 5 here. Now, in my head, when I'm thinking of those outer and inner swoops, outer swoop, inner swoop, I have 5y and I have 3y. Can I combine 5y and 3y and get negative 2y? Yes, if I have a negative for my 5 and a positive for 3. So I do a negative in front of the 5 and a positive in front of the 1. Now it's factored. So see how the first spots, if I FOIL it out, first spots make 3y squared. Outer and inner make the negative 2y. Last makes the negative 5. So we're good. Okay. All right, moving on to the next one. So I have 6x squared minus x minus 2. So I'm going to do my two sets of parentheses. For the 6x squared, I know I need either 1 and 6 or 2 and 3. And for the 2, I know I need 1 and 2. I always pick the numbers that are closer together. Like, I don't like to use 1 and 6 I like to try the 2 and 3 first, meaning like 2 and 3 are close together, like the numbers on the number line are close. I usually try those first. So I'm going to try 2x and I'm going to try 3x. Now here's the main trick that I was talking about. You're going to learn tricks with this guess and check method. Okay. In my original thing, 6x squared minus 1x minus 2. Did I have a GCF? No, I couldn't pull like a 2 to the front or anything like that. Do you guys understand? Pay attention. This is important. Save you hours on your homework, I promise. Not hours, maybe minutes. All right. Okay. Okay, don't show them another way. Trust me. I've taught this for many, many years. Probably 10 years. 10 years, actually. Taught this for 10 years. The problem with teaching the other methods is people forget them. So when it comes time for the test, you're going to forget it. I promise. I've done this for years. If you relate it to FOIL, it's better. All right, so let's say I put a 2 in here. What if I put a 2 there? Do you guys see how I have a GCF? I can pull out a 2 here, right? They both have a 2 in common. That's bad. If I didn't have a GCF in the beginning, I should not have a GCF later in the problem. It's like saying 100 is not divisible by, I don't know, 26, but then all of a sudden you have 26 as a factor, right? That's not going to work. It doesn't work that way. Okay, so do you guys see this is the shortcut that I'm talking about? You do not want to put a 2 here. You don't want to put anything that would have a GCF with that 2. So I only have one choice. I can put the 1 there and the 2 there. Now when I check my outer and inner, I have 3x and I have 4x. So I have a negative and I have a positive. That's what's going to combine to be a negative x. So I need plus and then I need a minus. Now it's factored. All right, C. The GCF, yeah. So we'll do a lot of these and you'll see. All right, so I have 8z squared minus 36z minus 20. Do I have a GCF here? 4. Yeah, so pull it out to begin with. Right, because that makes it easier, because now I'm just dealing with 2, which definitely is 2 and 1, and 5, which is definitely 5 and 1. So I have the 4 on the outside, and I'm going to do a parenthesis, so I'm going to have 2z and z. And then I need the 5 and the 1. Now, are you guys getting to the point where you're visualizing the outer and the inner? I want negative 9. Do I put the 5 here on the left, or do I put it on the right? See if I put it there? I get 10z and I get 1z. Can they combine to be negative 9z? Jason, Faisal, pay attention. 10z and 1z. Yeah, if I have a negative here and a positive here. So I do plus and I do minus. Just make sure you didn't mess up your signs on the very last thing, right? They do multiply to be negative 5. So we're good. All right, next one. Okay, so I have 12x cubed. So 12 could be 1 and 12, 2 and 6, 3 and 4. And then 6 can be 1 and 6 or 2 and 3. So let's say I pick the 2 that are closest together, the 3x and the 4x. Okay, this is what I'm telling you can save you a lot of time. If I choose the 2 and 3, I don't want to put the 3 here and the 2 here. It can't work that way, because then I'd have a common factor. I'd have a 3 in common, and I have a 2 in common in the second one, right? But I couldn't pull anything out originally. So it can't be like that. So you've eliminated half your choices, right? So I can't put a 3 on the left and a 2 on the right. So I'm going to switch it. I'm going to put a 2 here and a 3 here. Now looking at the outer and the inner, I have 8x and I have 9x. Can you combine 9 and 8 to get 1? Yes. Yeah, if I have a positive for the 9 and a negative for the 8. Done. Okay. Now usually when I have a small number in the middle, like see on part D how I had a 1x, right? It's usually when you have numbers that are really, really close together. And that, like I said, those are the ones that I try first. I usually try those numbers that are close together, like 3 and 4 versus 1 and 12. But notice on this next one I have 61 in the middle. It's kind of hard to get 61. So let's say I tried 5x and I tried 2x. And then I thought, oh, factors of 6, I'm going to do 2 and 3, but I know I can't put the 2 here, so I put the 3 here, and I put the 2 here. Look at your outer and inner. Are they anywhere close to 61? No, 15 plus 4, it's 19. It's not nowhere close to 61. So you could try, like you can try the 6 and the 1, but it's still not anywhere close. It's 30 and 2, right? 32. So that's when you want to think about like the extreme values. You want to think about like the big ones. So I want 10x and I want x. And I'm going to put the 6 with the 10 and the 1 here. Do you see how that's going to work? 60 and then 1. They're both negative. They both have to be negative in order to multiply to be positive 6. All right, we'll do one more. So this next one has a GCF. Yeah? Just because the outer and inner, when you combine them, they were nowhere close to 61.
Oh, so
Yeah, so you had to go like big on the outside. See how these are both the big numbers? And these are both small. Okay, so I have 5x. Oh, sorry. Let me pull out the 2 first. So I have 5x squared plus 17xy minus 12y squared. So this is one, and you have a couple like this on your homework, where you're going to need x's and y's. So if you want 5x squared, we're going to do 5x and x. And if I want 12y squared, I could do 1y and 12y, or I could do 2 and 6, or 3 and 4. Let's try the 3 and 4. So let's say I put the 3 here and the 4 here, but I want y's with them. So that way my outer and my inner give me 20xy and 3xy. I need positive 17, so I need positive 20 and negative 3. So negative and positive. That's how it factors.